Welcome everybody. I'm not sure I ever had such a crowded audience that I can recall, so wow, let me say wow. Really happy to be here at Developers Day, and it's not the usual sentence that speakers say just to look nice to the audience. Anyway, this talk is about an approach to software development, to developing certain parts of software that by name is popular. Everybody seems to understand that. Domain modeling, building a model for the domain, whatever is the formula that you prefer to use to express that, but in practice, I'm not completely convinced, and I say that by experience, that really everybody knows what it means. So this is an exercise, hands-on experience, what it really means to design a domain model. Let's This is my favorite joke, okay? Okay, I want to be serious now. I cannot be serious. Okay, no problem. It all starts from the definition we use for business logic. Because domain modeling and business logic are, in a way, conceptually speaking, tightly related. And at the very end of the day, what we try to do when we design and implement a domain model is we are just finding a way, an alternative way to express, to put in code, business rules and business logic, to some extent, business workflows we have in the domain we are trying to address with our software. But let's start from the abstract definition of business logic, a definition of business logic that we borrow from domain-driven design, the well-known popular methodology for approaching and dealing with the complexity of huge, or today I would say every software system. So we can recognize, according to the DDD vision of software development, two flavors of business logic, the application logic and the domain logic. And I would say that the reason why 15 years ago, when domain-driven design was first introduced by Eric Evans, we had just the notion of business logic, and many gray areas existed around that definition. For example, I know that my application requires that the data is formatted in a certain way for display. But which part of my code should really deal with the formatting of the data for display? Is it the portion of the code that does the calculation, implements the rules? Is it purely presentation? Is it something in the middle? There were many. Everyone had his own solution. Everybody claimed that that solution was the right one, the perfect one, but actually it was a gray area. In domain-driven design, we had this problem solved at the root by saying that we have no longer a comprehensive entity we call business logic. We have instead two distinct layers, the application logic or the application layer and the domain logic part of the domain layer. So what is the application logic? What part of what we have called for decades business logic falls into the application logic? The part that is dependent on use cases. And you know, a use case is a reason why a user has to interact with the system. So it is strictly related to the presentation layer. If you have a screen, a form, a button, an actionable item that you display to users, or whatever is asynchronous or synchronous, the way from the outside world, users included, to interact with the system, that is a use case. And whatever logic we have in touch with the use case is part of the application logic or the application layer. So every piece of code we need to have to format data for display purposes or to turn input data into a format that is easier to work with, that is responsibility of the application logic. And we might have application-specific entities to represent the data. Sometimes this is called, more recently, the view model. The domain logic, instead, contains the portion of the business logic that is invariant to use cases. It is not dependent on the way in which we receive or have to return data. It is the engine. It is the real business rules implementation. And it means that the application logic can be duplicated, perhaps, if we have multiple front ends. And the most common scenarios of this is when you have a mobile application or even a web mobile front end that is significantly different from the regular front end, the desktop front end. The domain logic is instead unique and shared by any application and presentation layer you may have. This is the classic canonical layered architecture we inherited from a domain-driven design, presentation, application layer and domain layer, and then infrastructure with persistence. This kind of architecture is slightly, evolving into a part that is one of the many flavors of a pattern called the CQRS that can be represented in that way. Presentation layer, application layer with the domain layer infrastructure on one end in the command stack, so in the portion of the system where we only deal with whatever action alters the state of the system, and on the other end, so in a sort of parallel implementation stacks, we have just the part that reads the state of the system. And then the interesting part of these diagrams compared is the black blocks domain layer. In a canonical layered architecture, we have a unique layer that deals with the logic in the domain that is shared by actions, use cases that alter and don't alter the state of the system. Instead, if we evolve our system design towards the CQRS pattern, the domain layer, so the part where we alter the state of the system, only belongs to the command stack. And the read is simply a way to do plain queries from some persistence store. CQRS. Just a joke I found out this morning. How do you pronounce CQRS? Okay, take a picture of me with this now. Come on. I want everyone to tweet this. Okay, CQRS. Okay, so domain layer in the classic or CQRS variation of the layered architecture, there is something called the domain layer. So what is the difference? I use the domain logic and domain layer. What is the difference? The domain layer is made of two components: domain model and domain services. The domain model now There is a design pattern made popular by Martin Fowler called domain model pattern. But at the same time, the term domain model was coined more or less at the same time in which Fowler was publishing the pattern in books and writings that he did by Eric Evans in the Domain-Driven Design official book. But actually, in the Domain-Driven Design book, the term domain model is part of a slightly larger expression, a software model for the domain, for the business domain. That has been now cut short into a domain model. But the difference is, when I say a software model for the business domain, I mean whatever in software helps me to faithfully represent the business domain. So in this expression, there is nothing like a subliminal paradigm like object-oriented. So domain model is essentially whatever helps us to represent in software the entities active in the domain. It may or may not be an object-oriented model. So it may or may not be an implementation of the domain model pattern, which is essentially an object-oriented pattern that we may find described as soon as we try to Google. Domain services are the part of the domain layer where we essentially get in touch with the infrastructure. So one of the misconceptions, most important misconceptions around domain-driven design, and in particular the way in which we express the domain model is, okay, instead of having my database tables and using database-oriented tools to load and update my records and memory, I just do that using classes. So instead of having my data set or record set or similar database-friendly tools, I just have classes. And frameworks like Entity Framework just suggest you, okay, you just create your classes, or we can infer classes for you from a connection string. You have classes, you deal with classes, but those classes are one-to-one, essentially, with the database. So there is a sort of attempt to decouple code concepts and database persistence. So in short, the common idea around the domain model is it's an object model, object-oriented model, so a bunch of classes related together that we have to, in some way, persist to a relational format. And that is a description. But in domain-driven design, when you hear summaries of that, there's another sentence that is kind of scary. Persistence is not relevant, or the database is last of your concerns. When you design a domain model, you completely ignore the database and how you persist that. This is kind of scary, or at least shocking, because when you read this definition of the domain model pattern, an object model, it is an object model of the domain that incorporates both behavior and data. Okay, nice. Instead of, it means, the common interpretation is instead of just having there public properties that map more or less closely to columns in my database, in tables of a database, I need to have behavior, so methods. What kind of methods? That's the point. And 99% of the time, let me exaggerate on that, the idea we have of the behavior, of the methods we should have on the classes in our domain model are CRUD methods. So methods to explicitly create an instance, so create a new record, update a record, delete a record, report, read a record. Okay, so we can even imagine to have our customer class to represent the content serialized on a customer's table. This customer class, we expect this class to have methods like load and save. Load, and which takes, for example, an ID, parameter, integer, string, whatever it is. And this is completely against the vision of domain-driven design and also the idea. So, no, don't do this. Don't do this, but in which way then I should be doing things? So when we want to approach domain models, essentially we should move away from the idea of CRUD, create, read, update, and delete, and move towards something different. How different? CRUD stands for, the C is create, R is read, and then update and delete. The real problem in the transition from CRUD to domain modeling is in how we handle updates and deletes. Because the C creation, well, it's about creating a new instance of something that a factory or even a constructor can do. So that's easy to do it, to understand. Read, okay, we just report the current state of this object. The problem is the U and the D. Because in the business, when we deal with business rules and business logic, we read data from some persistence store, or we create new entities to be saved. But these entities, once created or once read, are subject to operations, business operations, and the state changes. It's all about how we express, how we let developers, including ourselves, to alter the state of the information we have read from tables in a way that instead of being a plain, silly, dummy update of cells in a database table, is done keeping an eye on the business rules and the business words and actions. In other words, what domain-driven design means, or was meant to say, is in the domain logic, we have a domain model that contains just the machinery, just the implementation of rules, just the engine. Okay? And when we create the domain model, we do that, we code there only the basic rules, the mechanical rules. We say nothing about the fuel we put into the engine. It's just how the engine should work. And the fuel that makes the engine work, providing that, is what a domain service can do and should do. So in other words, every action becomes out of the interaction of the two parts of a domain layer, domain services and domain models. The domain service is responsible for loading from whatever persistence you have the data and to return a fully populated, consistent instance of an object that belongs to the classes in the domain model. The domain model exposes an API, business-driven, business-oriented, for coders to alter the state, and then once the state has been altered, the domain service again saves it back, altering the state of the system. So it's about splitting. So the load and save methods are out of the domain model and they belong to domain services. So you call a domain service to get an instance by ID. So that's the classic query you would do in a CRUD world. Then you use, instead of making plain stupid changes, editing directly properties, you wrap this into methods that express the expected logical behavior for that entity. And when the state has been updated, you have another consistent state for the entity. You pass it down to another domain service, which saves it back to persistence. This is how it should work. So, domain model is a conceptual model of the business domain in which entities, classes, model the behavior and contain the data of the entities that they are representing, taken from the real world. Two key points: a domain model doesn't have to be necessarily object-oriented. It can even be functions. Most of the time, simply because object orientation at the moment is a mainstream programming paradigm, that is the only reason why most of the time domain-driven design, domain modeling is associated with classes. It could be functions. And more importantly, when you plan to have a domain model, whether it is functional or whether it is object-oriented, you should think of it as the API, the public API of your business domain. So in other words, there is the Murphy laws, right? If something can go wrong, it will. There is the Murphy law of developers that says if a developer can use an API the wrong way, it will. So it's all about managing to create code in such a way the Murphy law of development doesn't apply, or not that often, at least. So think of it as an API. It means that you should guarantee in the design, in the programming interface, that whoever gets to use that class, given the state of the class, is only allowed to do consistent, reasonable, legitimate, legal operations. And basically, in all this context, persistence is not a concern at all, because we should focus only in how we make an instance of a domain element, entity, function, or class evolve consistently given the business rules. And persistence is simply, okay, before I proceed, I need something that loads data and gives me and serves me an instance with the data inside. And once the state has been altered, I need another external thing that takes the current state out of the entity or function I have and saves it back, so that next time it can be reloaded. This is the point in which we say persistence is outside domain modeling. Now, let's go into coding mode. So the rest of the talk is about giving a practical demonstration. And I have picked up an example that comes from my direct experience, and it's also probably fairly easy to grab, and it's not as boring as, dealing with orders or customers. So the problem is design an object model to be supportive of a scoring system for a sport of your choice. In particular, football would be too simple, honestly. Stupidly simple. You score a goal, you don't score a goal, period. That's it. Tennis would be too much complicated. Scoring, I know that. Scoring, it's really problematic. So I picked up for the demo water polo, which is something in between. So water polo counts goals, like in football, but it has 4 periods rather than just 2 as in football. And then this is the design of this class is coming out of my experience as a user, because my son did water polo for many years. So I spent countless weekends to driving him in pools all around Rome, and the idea was to create a software system that the umpire assistant could use to track the current score of the match. And then looking at what was the behavior, the actions that real users did in the real world, I figured out that, well, there was the umpire arrived in the pool with the assistant. They sat down. They, in a way, called the teams to warm up. So they got into the pool and start, warming up swimming. At some point, the umpire went through a number of checks, for example, checking nails of players, and then it's called the match started, putting the ball into the water, and then it was stopping and restarting and stopping the game for timeouts, for faults, for whatever reason he called out. How would you represent all these things in software? Now, apparently, it's a stupid problem. Not really the good example you would expect. You would have expected. But let me switch to Visual Studio now. So the first approach, the first thing that I thought was, okay, I wanted to build this software system not for the umpire, but actually for me or friends going out to, for the weekend to follow the match. The idea was they could push a few buttons on a mobile application, update a database, and a service will expose, so we can follow from home the live score of the match. That was the idea, the practical idea. So I had to provide something for people to use, for one friend to use on an Android device to push a couple of buttons, goal, 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 or timeout, goal, 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 and then that information would have been reported and exposed as a service for another app to show the live. It was all about saving the state match. So why not this? ID, so I had to create stupid SQL Server database with a match ID that was a number. Team 1, Team 2, okay, venue day, the current score. Because I'm a good developer, I say, oh, the score. The score is what in DDD is a value type, so it's an immutable kind of thing. So let me create my own separate class. And I was proud of that, so I called this class score. And I said the score indicates the total number of goals for both the teams, the current period, and whether the ball is in play or not. So is the play suspended or not? The match has a score, also has a state to be played, in progress, or finished. And I was kind of proud of that. It's nice. I mean, it's very simple but pretty nice. I also added is in progress, the Boolean method. So the class was elegant, apparently, and lovely, just lovely, and straight to the point. And it works. It definitely works. But remember the point. The real issue is how you update and sometimes delete. So the U and the D operations of code. Now, let's focus on when something happens, when an event happens, you have to alter the state of the match. And which are the events that realistically, given the context, can alter the state of a match. For example, when a goal is scored. And when a goal is scored, all that we have to do is, according to this class here, we take the current score, we pick it up 1 or 2, depending on which team scored the goal, and we increase that property by 1. And it works. It works, but we are taking the responsibility of doing things right. Remember what I said, when you create a domain model, you are actually creating an API for the business and the Murphy law. We are violating, we are exposing ourselves, CQRS, to the Murphy law, because we are giving too much power to developers, any developer using this API. It's not an API, actually it's do whatever you want. Total goals 1 and 2, they are marked as integers. So it means that, according to this API, minus 3 million to 10,000 is a valid score. But it's not a valid score in the business. Okay, we don't want negative numbers. Okay, let's mark these unsigned integers. 0 to 5 million is still not a realistic score. But there is more. Okay, let's say we can cap. We can find a way to cap the integer for total goals 1 and 2. Even if we restrict the type, it's still an issue. Because as long as we leave that to be just a public properties with a public setter, or even if we put a setter method as a separate entity with some logic inside, it's still about free setting of the property. I mean, in a real world, the total goal of a team is 0 in the beginning, and then from 0 it can only go to 1. And from 1, it can only go to 2, and then to 3. It can never take any value in a given range, jumping from 0 to 4. No. It has to progress 1 by 1. That's a business rule. You never know that. Yeah, it's a business rule, actually. So the evolution of the score follows business rules. And the same can be said for current period, which is limited to 0 when the match has not started yet, 1, 2, 3, 4. And from 0 it goes to 1, it goes to 2, it goes to 3, it goes to 4, and that's it. At that point the match has been finished. But there is even more, other business rules. If the ball is not in play, I cannot score a goal. I cannot record a goal, because there's no game actually in play. If the match is suspended, no goal. If the match is not started, no way I can score a goal. So this is the problem of updating the state of an entity, of a business entity, according to business rules. If we take the classic crude approach, we totally fail on this. We can still have functional code, no doubt. We've been doing this for decades. We can still keep on doing this. But actually, think now. In the beginning, you didn't realize all the impact of all these subtle business rules. So you use a crude approach to create this system. And then, now, if you are the author of the backend and the author of the user interface, you manage to have the user interface so that bad things cannot happen. So it's the UI that allows you to call through buttons to push methods that change the state of this backend entity in a way that is legitimate, that goes hand in hand with the business rules. But now, in a larger environment in which you are only responsible for the backend and you have no control over who's going to use that and how they are going to use that, You are giving out an API, because this is an API, that allows to do a million different things outside your control. So the people using your API at that point are forced to learn themselves the business rules. So you are the guy responsible for the backend, but users of your work must know business rules themselves, because they must call your API in a way that is respectful of rules. So the knowledge and also coverage of business rules spread out well beyond the realm of the domain layer. And this is an issue. More, if you keep this class essentially anemic, so without logic, business logic inside, the business logic must be placed somewhere else, so outside this class. And it's really tough to put together. Think, for example, of just the updating. You may have a method like, add goal to team 1. Okay, you go there, you take total goals 1, and you increase that by 1 internally. But because scoring a new goal requires checking if the ball is in play, if the match has started, all those ifs must be checked before you can call add goal, or must be checked within the body of add goal. You still can find a way to put all these rules together, for sure. Again, we have been doing this for decades. So no doubt we can still keep on doing this. But the point is how efficiently we can go on. So let me show you a totally different way of rewriting the match class. Business. Here we go. The first big difference between this and the previous one is the constructor. Now, domain-driven design tells that you should be using factories. The only difference between a factory and a plain constructor is that a factory can have a name that you decide. Okay? And you have because it's a separate method, you have more control over the signature, the prototype. But beyond this, there's no difference between having a constructor, like in this case, or a factory. So this means that the only way I have in my API to create a class is when I specify a valid ID and team names. Without an ID and team names, I cannot have a valid instance of the match. This is the first point in our API. And if I expand the constructor, you see that, I don't have here, because I'm lazy, checks that ID and team names are not null. And then, taking this even farther, it should be said, who decides the match ID? Is it a friendly match? Then it can be any unique value. If it's not a friendly match, but it's part of a championship, it's not you to decide the ID of the match, but it's the organization that schedule a match between well-known team IDs, team names, and there's a match ID, there's a venue, there is a date. So all this info that I placed around here in a realistic application might originate from very specific places. But beyond that, let's focus on the state. The state of the match by default is to be played, and the current score is a new instance of the score class. So the current period is 0, the ball is not in play. Once I have ID, name, and name, I have a match that has a state consistent with the business rules. Okay, Next. All of the properties I have here are have only public getters, but private or internal setters. It means that I can read ID, team 1, team 2, state, current score, ball in play, current period, but I cannot set directly any of those. Why some are private and a couple of them are internal? Now in C#, the difference between private and internal is that if it's private, it's private. So only the class, so that property, that field is accessible only within the realm, the boundaries of the class. If it's internal, the boundaries are slightly larger. So in both cases, those properties cannot be accessed from the outside of the class. But if it's internal is consider it public, but only within the assembly that this class belongs to. So the reason why I'm doing this is as a sort of a shortcut to have a domain service to inject a state into a class. Remember what I said, the stairs slide of a few moments ago? To use an instance of this match class, you need something, typically domain service, that makes a query on the database, grabs the data, a record, the real record data from the database, and then injects that data as a state into an instance of this class. Which means it tells the match class, hey, look, this is your teams, this is your ID, and we can do that through the constructor, fine. But I also need the domain service to be able to say, hey, look, this is your current match score, and this is your current state. This info must be injectable, but not publicly. That's why I use the internal kind of thing. I also added a bunch of informational methods. Is in progress, is finished, is scheduled, and they are simply checks around the match state property, just for readability, nothing special. And then the behavior. Now, this is the list of methods I have in this class. I have start, finish, goal, start, period, end, period. And those are faithfully describing the types of business actions I can take, anybody is allowed to take on this class. That's the API. Now, expanding these methods, you will see that there is nothing like loading state or saving state. I assume the class to have a consistent state, and those methods simply allow to transition to another consistent state in full respect of business rules. That's it. And when the new state, after calling any of these methods, has been reached, if needed, I can take the current instance, pass that to a domain service, which will use persistence API to save it back to SQL Server, NoSQL, whatever you like. Now, don't think that there is such a complex logic in these methods. Let's start with the first one here. What happens when you start a match? You simply set match state to the state property to in progress. That's it. However, the commented line, which is commented simply because I don't have references on this machine to the external tools of the contract API. Using the contract API or simply using an if statement, you can check that if the match is not scheduled, so if the match is not in the to be played state, you cannot start it. So we can expect to have here something like Something like this. I want to make sure that I can call the start method only if the state of the match is compatible with expectations. Next. Finish. State equals match finished. But before I can consistently guarantee that the match is finished, I should check that the match is in progress. The period is the last one, and the ball is not in play. So I can call finish, but not at any moment in time. To be able to call finish without issues, exceptions being thrown, finish must be called at a particular moment in time. At some point after a certain sequence of operations have been done. The logic of this demo doesn't take into any account if the match is suspended. It adds more rules to the solution. Start period. Again, if you observe what happens in a sport match, the match is started when the umpire or the referee are on court. But there is typically a warm-up time. So there is a state in which the match is in progress, but the period is still 0 because the match hasn't physically started yet. In water polo, okay, it's the time, the 5-10 minutes in which the players' nails are checked, in which the teams are allowed to warm up. They take their position in the pool, and then the umpire goes to the side of the pool with a ball in his hands, drops the ball into water, and whistles to officially start the match. That is when you start a new period. Start period. Start period here can be called if the match is in progress, of course. If the ball is not in play, because the ball gets in play the moment in which a period starts. And we increment the counter by 1. Increment is simply an extension method on integer that does +1 up to 4. So it's there written that way, simply as a form of ubiquitous language, just to use in code names that are familiar with the business. And after we started a period, the ball is in play. And the period, because there is a start and there is an end of the period, with possibly a pause in between the two. So we have to, if you want to faithfully model the real world, we have to have a start period and end period. In football, it's like this. And end period changes the state of the match. The ball is no longer in play, and we can call end period if the match is in progress and the ball is in play. We change the status of his ball is in play, and if current period is 4, so if we reached the end of the period for the last period, we call finish. Automatically, but this is arguable. You may or may not do that. You may, depending on the expected user interface, you might want to have a finish called explicitly through an action or called automatically at the end of the last period. That's a design decision. And now the most interesting part of the story. What happens when a goal is scored? Goal is a method that takes a team ID, so home visitors, so which of the teams scored the goal. And to be able to score a goal, the match must be in progress and the ball must be in play. And now for the purpose of the next demo, I just physically coded here a couple of ifs to implement the contract requirements commented out. So if the match is not in progress, you throw an argument exception, can't score a goal if the match is not in progress, and if the ball is not in play, cannot score a goal if the ball is not in play. And then if team ID is home, we change the current score of the match, creating a new score value where total goals 1 is incremented. Otherwise, we do the same on the other property, incrementing total goals 2. So now that we have this API for representing a match, we are exposing to others an API that they can use with a certainty to be in line with business rules, whatever they are. And to give you concrete demonstration of this, let me show you a couple of unit tests you can write. There we go. This is a possible unit test you can have. Test score is correctly set. Match, new match, 1, 2, 3, 4, 5 home visitors. Match start. Start the period. Goal for team 1. Goal for team team 1. End first and period. I don't know what I call end period. I don't know if it's first, second, third. I know that the umpire called the end of a period. Point. If in my code, after having called end period appear, okay, if with the state reached at that point, I want to know what is the current period, I can still read the read-only current period property. So the state is still fully visible. All the details of that are fully visible. Except that to alter the state, I only have methods. And methods are now fully respectful of the observable behavior in the real world and the rules that have been taught as a development expert, but not a domain expert, to be in place. Next, start period, goal for visitors, end period, start and end period, start period, home and finish. And now the final assertion. What is the score? Is 3-1? Yes, no. We'll see. That's a unit test. But there's another one I can write. New match, start period, end period. If I call goal now, so right after the end of a period with ball that is not in play, I should get an exception. And we can see that if I comment this out and just run unit tests, I get I have one test failed. Cannot score a goal if the ball is not in play. And if I instead re-enable this expected exception and start again the unit tests, I should have all greens. Yep. This is what I mean by saying you should be creating an API and exposing the behavior of your domain entities as an API so that everyone who gets to use your code can do that with the certainty that unless there are bugs in your API, it works. And even if there are bugs in the API, especially if you paid attention to the choice of names for methods, for classes, even through extension methods like increment there, if there is a bug, it could simply be that the bug is there because you missed some business rule, or some business rule was not completely clear. So when you have feedback from your customers, the customer typically speaks business language. So the nice thing is that the business language, the way in which she tries to explain why the code was not working the way it should, she probably uses terms very, very close to the methods here. So it's even easier for you to figure out what was wrong. And to figure out, so if I say, let's say that I missed in my code the line, this if here. Suppose that this code was not part of the source. This line was not part of the source code. During tests, the customer figures out that, hey, look, but if I click score a goal during the pause between, say, second and third, I inadvertently clicked the button score a goal in the pause between second and third period, and it added a goal, and I had to undo the operation. That's a bug. Oh my God. Because you are not allowed to score a goal when ball is not in play. No, I'm sorry. I mean, in the discussion terms, conversation is closer to the real business and closer to the actual implementation, the actual structure of the code you have. Okay. Final comment is, now, in a layered system, you have a domain layer in which you have a domain model that contains an implementation of the match class with methods like start, finish, goal, and timeout. And then you have domain services, which are responsible for essentially the persistence of the information associated with the match. Now, how you persist this information? So information is just data, the data that fully identifies a match, the state of a match. That is what you need to save. You can save that in a text file, as a comma separated, as a CSV file. You can save that to a NoSQL database. You can save that, and that would be the most common situation, to a SQL Server database using Entity Framework if your company is a Microsoft shop. And the moment in which you start using Entity Framework, and you have, say, a matches table in the database, Entity Framework expects you have another match class that it can persist, and the match class is one-to-one with the physical table. Now, it could be that in the real world, the match class is just the one that we created with public methods, because we still have properties there with public getters, and Entity Framework does everything through reflection. So Entity Framework can even read and set properties we marked as private. Okay? But conceptually, the match class with methods like start, finish, goal, and timeout, and whatever, that is completely different and should be physically different from the match class you create as part of the Entity Framework persistence model. And ideally, if you have these two match classes, you also need to have some extra code that moves data between the two, that adapts, moves data from match to match. Match in the persistence model and match in the domain model. Of course, the match in the persistence model is the matched class we started from, with one-to-one with columns and public getters and setters on every property. Because we want to save a lot of work, sometimes we manage to have to create the domain model class with methods in such a way it can be easily persisted. So we have just one class to maintain. But conceptually, we are talking about different things. Thank you very much for your time.